Welcome back, generals, to another Let's Fix Generals 0 Hour to make the best game ever. And we are back with unassemblize, and there was one thing that came to my mind today as I was thinking about the bit array. I think we can improve this further. So basically, I was a bit upset that for setting and getting, we always have to do this here, which is not a big deal, but I think we can do better by creating a struct bit bit yeah, let's just call it bit. And in there we would have a bit. We would have a so we would have a private uint8 yeah, well, it would have to be a reference. Which is pretty big. And then we would have the bit field or bit mask. Bit mask. Bit mask. And then we would have a bool is set const, then bool void set and void unset. A set we would simply return here this thing bit array so bit mask. Then here we would do set is to bits bit mask, and unset we would do bits this bit mask. Right. And then on get we would do get bit index, and then here we would return would have friend class bit array private bit bits Maybe we do m bits m m m m m m. There we go. And bit mask uint 8t bit mask. There we go. Bit mask. And now we can create that here. Return bits with bit index and bit field, aka bit mask. Put that in here. All right. Okay, so basically we would get a bit, and the bit would only unfortunate thing is that it's so big. Can we make it smaller? Problem is it needs this pointer. It would be nice if it was just 8 bytes. But we can't do it because bit index, bit mask. Yeah. Maybe we call it bit. I mean, bit is bit array, bit. Yeah. Get bits. Bit index, bit mask, bit array. Yeah, it would be nice if we could make it smaller, but I don't know how. But the advantage of this is that we basically get this bit thingy, which contains here the pointer to this element here. And then we can read it and we can set it, right? And then we wouldn't need these two functions. We would just have this get function, and then you can operate on this. And this we can make default false. Yeah. And the size here, M size, how are we using it? Size, yeah. Bit. Okay, it would be nice if we could make this smaller. 8 bytes. 8 bytes. But how? It would need to have an index, and then we would need to pass a bit array in here to index it. right? But that makes it a bit complicated to use now. Or we make some mix of this. We say we can maybe call this bit indexer. Yeah. Let's make a copy of it. So take this guy and we create a new one. We call it bit indexer. And the bit indexer takes a how about we make a uint 32t bits index how much is programmer 1 shift 40 1 shift 24 16 million 16 million. That's a lot. That's a lot. How about we put how about we make a artificial limit assert h assert size smaller than 124. Maybe we should make a uint 32t size index and then currently has a limit. Currently has this limit to provide compact bit indexer. Okay, then we say bit index 24 and bit mask 8. Then our bit indexer is 4 bytes. And then we have here these functions here. is set, and we say get indexer, bit indexer, index, bit index, bit mask, and then we say bit indexer, bit array, bit index, bit mask, and then we can use this bit indexer here, bit indexer, we call it indexer, and then we use indexer, then we comment out all these guys here, and we pass here un32t bit index, here bit index, and then we say unset is let's make a copy of these guys. So we do bit indexer, indexer, just a copy, and then we remove this stuff, indexer dot bit index, bit indexer dot bit mask. There we go. And then on set we do the same. Ta-ta, ta-ta, okay. Indexer. Then we remove this guy. Okay. And then on isSet we do return to this bit array, this, that, this, bit mask, this, that, is set, indexer, bit mask. Okay, so basically the bit indexer is totally opaque. Actually, this private needs to come back here. So like, we can't do anything with the indexer. We just get it. It's like our indexer. And then we can use it to check like, okay, what's up with this guy? We can set it, we can unset it, and we can check if it is set with the same indexer. Yeah. Okay, this sounds good to me. Makes it maybe a little bit more complicated to use, but it's a tiny bit more efficient, I would say. Right? Well, apart from this here, needs to shift here and mask a bit. Yeah. Is set, set, unset, get indexer, index. what we could also do is, hold on a minute. Okay, what we could also do is add some functions here. Bit indexer get un32t get index. So that would return would calculate the index it's at. So bit index times 8 plus bit mask okay, before we do that, we could also have a well, we don't have any use for this right now, but we can do let's remove this here. Bit indexer. Well, we could also call it iterator. Bit iterator. Bit indexer. Bit indexer is okay. Bit array. So we could have next void next. And that would but how do we do it? We would have to, well, we don't have a use case for it right now, so don't test it really. So we would have to increment the bit here. How do we bit mask to bit position? What the fuck? What? What is this? What? Yeah, we don't want to do that. Count once. Bit mask. I just want to find out set bit positions. I just want a 1 bit mask to bit position. Let's ask our friend ChatGPT. There's probably some stupidly simple answer, but somehow I'm not seeing it right now. I have in C++. I have a 1 byte value which has just 1 bit set. How can we convert this bit to this bit? How can we convert this bit to a bit position, to a number that represents the bit position within that byte? Zero to 7, yeah. Combination of bit built-in CTZ bit to position. Oof. Bit scan forwards. Oof. It's all compiler specific. The value is non-zero. Without intrinsics. Yeah, bit to position. Yeah, I want to avoid this, but yeah, I'm afraid that it's not possible. Return the current bit position. Yeah, but it seems like that this would be the way. So essentially, it would have a function here. Int 80 bit to position. Say bit mask. Bit mask. Bit position. Zero while it's shifting it to see. . Wait, we can't, hold on. If we do this here, we can just shift it up. Shift. Yeah. But hold on. What happens? What happens if we shift right? If we right shift a 1 byte value that has 128 sets, that has what happens if we left shift? What happens if we left shift a 1 byte value that is set to 128? However, it depends on the type. Left shifts. Shifting left means moving all bits to the left by the specified number of positions, filling the rightmost bits with 0. Unsigned 8-bit integer, the result will wrap around because the shifted bits are discarded once they exceed the width of the type. Value overflow occurs. Implementation defined behavior. What does that mean? Implementation. Assign an 8-bit integer is already problematic because the maximum value of int 8 is 120. Okay, make it a unsigned, please. Do you have unsigned? Here, unsigned. No overflow in 16 bits. Aha, left shifting beyond the width of the type, 8 bits, results in undefined behavior. Jesus Christ. Okay, well, what we can do is we pass a bit mask. Then we do, okay, next. So how about we do bit mask left shift 1 let's do uint 16t bit mask 16 equals this mask. Then we do bit mask shift, then we check if bit mask 16 is larger than basically it will be larger than FF, right? FF 255, yeah. So if it's larger than 0xFF, then, or for that matter, 80, right? So 80, that would be largest. Yeah, if it's larger than 80, then we'd say bit index equals in bit index, increment that plus bit index. And bit mask would be one, basically. One. Otherwise, we say bit mask equals bit mask 16 static casts uint 8t. Well, let's say bit mask zero xff. I think we can just static casts uint 8t. Yeah. But to be honest, like, we don't use it, so maybe we don't care about this implementation for now. Yeah. Yeah, I think we can delete it because we don't use it. Or get index bit mask. And let's delete it. We don't use it. Don't need it. Okay, so basically we go back to executable, no, mgui app. And actually, no, it was in process state here. Then we do bit array, bit indexer equals that. What? Bit array get indexer, right? Get indexer, and then we do is set indexer false, otherwise set indexer done. Maybe we call it bit indexer. There we go. Okay. Is set. Yeah. Okay, so this should work the same way, but maybe it's a bit more elegant. Maybe not. has this limit to offer compacts. Okay, do we have any size T's left here? No, we don't. Good. Okay, so this guy is 4 bytes, this one is 16 bytes. Yeah, it's fairly small. Okay, let's see if it works. Compare. And we click here and there. Okay. Let's put a breakpoint. Here, breakpoints. Bit indexer. Bit index 0, bit mask 128. Is set, false, okay. Let's click here. Bit indexer. Zero, bit mask 32. Set. Bit mask. Yeah, seems to work. Good. So I do all this. Oh, here we have some error. Okay, looks like something is not working right. What is it? Let's see. Bit indexer. Oh, bit index is 0. It's always 0. Maybe. Get index. Get index. Oh, I see. That's a problem. Bit index, bit mask. Bit index, bit mask. I wonder if we should just like put it in here. Index. And then put this guy here. And then delete this. Put it like so. Then here we put this. Okay, let's try this again. Okay, let's see. Bit index 3 now, okay. Okay. All right. Okay. Yeah, that seems to work now correctly. Okay. Okay, cool. Then we can compile this guy and submit it. Bit index. Let's make it const. Okay, there's one more thing I would like to document. Oh, we can do it in an exchange. So assert, yeah, bit index, bit mask. Hold on. There's one more thing I would like to do. Process state here. Assert index is smaller than this one. Smaller than this one dot size. Let's see if that's the case. Single bundle, select all, done. Single bundle, select all. Okay, seems to work. Okay, add bit indexer to bit array class. All right, good. And then next thing, I would like to put a to-do note because it's something we probably want to work at some point. So there's this compare button, right? So here, to do add button to compare. So add button to disassemble and compare all matched functions. To do add button to disassemble all unmatched functions. Yeah, something like this. I'm not really sure. Compare all. Yeah, I'm not really clear yet, like what exactly, but something along this line. So because right now this compare button, which maybe has an inappropriate name, this compare button only initiates a comparison, but it does not like it does not facilitate like assembler matching yet, right? It just like builds all the function lists and prepares everything so that we know like, okay, what is in there, what bundles, what functions are in these executables, but it does not yet do anything with it, right? So we could have a button that like does everything in one go. Otherwise, it's on demand. When you click a function, it does something, right? But there could be the case where you just want to load everything at once in one go just to see the status, right? And you don't want to go to the function list and select all functions, which is not a big deal, but maybe you just want to have a convenience button, then we could have a button here. Now, okay, so that would be it for the documentation. So next I would like to move things away here. Yeah, I think we should first move the comparison descriptor, or we start with program file descriptor. Move this away. Yeah. Do we actually use this thing here anywhere? We do. This one, I guess we use a lot, yeah. Program file ID. Revision ID. Yeah. Okay. Okay. I think we simply move all these three classes, structs, into their own file. By the way, we should add a little bit more text here. Array. Let's call this dynamic array, dynamic bit array to store to store and access bits with an index with indices. Prefer using this over std vector bool for efficiency, for space efficiency. Yeah. Okay. Then let's add this to the last commit we just added here. amend commits. Let's see if formatting is done. Okay. Commits. Yes. Okay. So what we want to do is in the ImGUI client, we add a program file descriptor .h, then cpp, then we add program file, what's it called, revision descriptor, program file revision descriptor, program file revision descriptor. There we go. Revision descriptor. There we go. Okay. Program file revision descriptor. And a program comparison descriptor .h. Program comparison descriptor .cpp. There we go. Program file descriptor, file revision, comparison descriptor. Okay, and then we add them to our CMake lists. Here. Okay, let me make a copy of this and this. And the next one is this here. And this one. Okay, there we go. Then let's compile this. Okay, and hopefully it will be easy to detangle these things. Just move them. Won't have too many dependencies to things. Let's see. So, so we have this guy, we have this guy, and this one. Okay. Then let's first put the boilerplate stuff here, that, and we call it program file revision descriptor, namespace unassemblize GUI. There we go. Then we take this. We copy it here. This is the file descriptor. Copy it and put it here. And that is the comparison descriptor. Then we copy this, put it in here. Includes program comparison descriptor. Then we go here, copy this. And say includes program file descriptor, and then this one includes program comparison, program file revision descriptor. All right. So here we miss a quote. Okay, so this should compile to begin with. It does. Okay, so then let's start moving. Let's start with the, what is this here? Program file descriptor pair. Where do we use this? Okay, it's used internally. Okay. Good. So what do we need to move? I think we need to move this guy here. How about we comment? Yeah, we comment it out first. So program. Okay, so we put this guy here. Then where do we really need to forward declare it? Yeah, let's do it the same way here. Take this guy, put it here, and then take this guy. Put that here. Program file revision descriptor. File revision. Includes cstd int. std int. Include memory. All right, and we take this guy and we put it here. Okay, let's move these two forward declarations here like this. Okay, there's a vacuum command ID. What is that? Worq.h. Okay, includes worq.h. worq.h. runner. Oof. It includes a lot. Structs includes string valid ID. What is that? Ugh. Here. Oof. Valid ID. Maybe we do static. Is that legal here? I'm not sure if it's legal here in this place. Invalid. ImGUI text filter. Includes utility ImGUI text filter. Lots of forward declaration here. Structs. Oh boy, auto str. Jesus Christ. Where's auto str? Options.h. Oof. Options.h. So there's still a question mark here with the invalid ID. Where's this used, this thing? ImGUI app, invalid ID, let's see. It's not used much, but it is used. Invalid ID. Sure. Invalid ID. Poof. File vision, this should be shared pointer, by the way. Okay, let's copy all these guys here. Program file descriptor. It's a lot, yeah. Program file. Okay, all this stuff here. And we put that into the program file descriptor here. And we remove all the ImGUI app thingies here. There we go. And then okay, so here we need a bunch of includes, FMT, core, and includes work queue, includes async work states dot h. And includes program file revision descriptor dot h and file system and that seems to be mostly it. Okay, then we also need to copy this guy here. Put that here. ID is 1. Okay. Invalid ID. So what do we do with the invalid ID? Maybe we just say maybe we make it here a member invalid ID. I don't know. Get revision ID, invalid ID. What we can do is we add a new file program file common.h and in here we simply put namespace unassemblize GUI and then we put in there this thing here. Well, I'm not sure if it's legal to have this outside the class. How's this one defined? Inline const expr. So we do a inline const expr. Okay, let's type it like this for now. Then let's do include program file common .h. Okay. Maybe in there we can put these guys here. Or these forward declarations. This one actually should be in namespace unassemblize. Yeah, and then we go to mgui app comparison. Oh shit. Fuck you. Command ID. Okay, then let's comment out these guys. And this invalid ID thingy. And to include program file descriptor, file descriptor, file revision descriptor, okay. Okay, then we take this guy and we put it into the file revision descriptor. Then we do here include program file common.h. Then we go to CMake list and we also put your program file common.h. All right. Back to this program comparison descriptor, we take this guy and we comment this guy and we put it here. On that note, I just realized this one shouldn't be file ID, right? It should be comparison ID. Okay, then here we do includes program file common, and then we go to take this guy here and we put it file revision descriptor, put it in here, and then we go to oh, I'm happy when this is done. Where's it? Here, this one. Program revision, no, comparison descriptor here, put it there. Okay, and then imgui app here, imgui app. Okay, file revision descriptor. Let's copy all these guys. Program revision. Okay, there we go. And we comment this guy and we put it in here. Then we take the imgui app cpp and we copy these guys. Program, was it? Comparison descriptor. Comparison descriptor, which is pretty huge already on its own. Yeah, it's pretty big. Pretty big, couple hundred lines. Oh, it's not taking any end here. Jesus. There we go. Okay, and we put it to here. There we go. Did I just like cut it now? Hold on. Oh, I didn't mean to cut it. Let's comment it instead. Good. So now we get a lot of compile errors here, obviously. So we need to remove all these guys here. There we go. And the same in here. Ta-da. All right. Good. And then we will figure out all the, yeah. So include async work state header and process state, include processed state and file content storage, include file content storage.h. Okay, so this seems pretty green. And this one needs a include optional, include string, and include common types.h, which probably means we can remove string. Includes async work state, imgui selection basic story versus imgui.h. Oh, okay, we need to include imgui header here. Include imgui.h. There we go. And this thing here, struct text imgui text filter. Include utility imgui text filter. Okay, anything else? Process state. Include processed state. Okay. What else? We got fmt, include fmt core.h and util include util.h and include program file revision descriptor and unordered set. Include unordered set. And that's it. That seems weird. Good. Then let's see what is left. No compilers here. Do we really need to include these two? Maybe we just include common types.h. Includes common types. Okay. So we got still some here. File system include file system. There we go. And fmt includes fmt core.h. Okay, anything else? Program file, common. Maybe we can put common types into program file common. But before we do that, let's see if we got any other compile errors, which certainly is possible. Then one more thing. Comparison ID. Okay, this one is actually correct. Okay, so what do we have here? Program file. Okay, I have no idea how this guy ended up here. Program file descriptor. Get program file descriptor. Get program. Okay. Ah, no, that's IMGUI app. Hold on. What is this? What is the problem here? Ah, there we go. Okay, anything else? Okay, let's see if that compiles. I can probably remove some of these things here. Okay, we got a bunch of compile errors. Okay. Undeclared identifier. Program. Ah, okay. Struct. There we go. Right. Pragma once. Include common types. Remove this. Remove this. And this. All right, program file common. All right, blah, 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 blah. Include memory. All right, and let's put here common program file common. All right, program once. All right. Maybe we'll move the space here. Ta-da. Okay. Let's see. Okay, we still get invalid time point. Invalid time point. Where is this defined? Here, invalid time point. Okay, let's put that in common program file common inline. Then we need a chrono. Include chrono. Actually, I think this should be part of the file descriptor. No, file revision descriptor. Where are the times? Here, chrono, std chrono. Let's include chrono here and put this in here. Invalid time points. Maybe we make this actually a member here. Static const expr invalid time point. Include chrono. And then we remove it here again. Remove it chrono. Okay, let's see if that compiles. Nope. Util async work state. Util isn't found. Util. Oh, I see. Common types. Okay, includes util.h. Use of undefined type. Where? ImGUI Win32. File revision descriptor. File revision descriptor. File revision. Executable. Here we have a unique pointer. Okay. So I guess the problem is that we have to include executable and PDB reader, maybe. PDB reader. I'm not sure. Well, yeah, that fixed it. Okay. Then let's go to imgui app and let's start removing some things. So we probably can remove all these guys here. And this optional thing, where did we use optional? std optional in a comparison descriptor. Comparison descriptor option is already in here. Okay, then we go to imgui app. Where's it here? And we just remove these two as well. And then here, I think we can unordered set file system. Maybe we can remove this as well. Scope we need. PDB reader we need options.h. I don't know about options. Maybe this can be removed as well. Let's try this. I think this works. No, it does not. What is the problem? Async load exe commands is unknown. Why is it unknown? Ah, because of options.h. Huh. I see. What header does this need? Runner async. Oh, runner async. Okay, let's put that back in. Okay, what about options? Can we remove that or not? Looks like we can. Probably because it's included somewhere here. Options.h. What happens if we remove it here? Error auto str. Okay, well, let's put it back. Yeah. Okay. Then let's go imgui app. Runner async. Right. Okay. Good. Algorithm. What was this used for? Huh. I don't know. Algorithm options. Good. Then let's remove all this stuff here. And all this stuff. Jesus. Getting tired. Oh, there we go. Okay, great. And then we can also clean this here up. Ta-da. And all this stuff here. There we go. Okay. Now this is a lot more manageable now. Yeah. One class without any child classes. And this one is still pretty large. 2,300 lines, but not as large. Yeah. Good. Breakpoints. Let's delete this. Okay, let's see if that compiles. It does. Okay. Let's look once more over our files. So here are all the forward declarations. So we have a memory for the pointers, comment types for the integers, some forward declarations here. Actually, I think these forward declarations we can put into here, right? They belong here because of these guys. Maybe we put, let's leave it here. All right, this, yeah, it looks good. Invalid ID, okay. Yeah. Invalid ID. Yeah, I think this makes it a lot easier to look at, right? Yeah. Work queue. Yeah, it's not so big now anymore. Well, this class is still quite outrageous here because it's still got one child with a file here, but I think it's fine for now. No need to split. This is manageable. Just 700 lines. Yeah. It's probably okay. Another set. Utah. Yeah, I think this is good, as long as it still works. Let's see if it works. So this so far looks good. Compare. It does something. It loads. We can change bundles. We can click. We can select. Select. We can filter. Yeah. We can select here. Functions. A lot of functions. Okay. Yeah, I think this works. Compare. Yeah. Okay, cool. Let's click here, compare. Oh, got an error. Oof. Selected match functions. More ID. Update selected match functions. Okay, let's look at this. This seems to be unrelated problem. Yeah. We first should conclude the refactoring. Okay. But maybe we can already check what the problem here is. Selected named function is this. Yeah, so somehow we still have this thing here. Is this never reset? It is reset here. But somehow... Yeah, there's somehow there's an error. the selected name functions has more indices than we would expect here, right? I mean, this is outrageously much. Yeah. Selected name function indices. Functions that are visible and selected in the UI. Yeah. Okay, let's debug it after we have... Well, we can actually merge right now. Yeah. Okay, let's see. So we program comparison descriptor. Yeah. Okay. util.h. Okay, so moved all this stuff out. Yeah. I wonder, can we put the runner async? Maybe it can be put into the... Ah, it's not necessary now. Okay, so I think this looks good. Yeah. Good. Then we commit this as move imgui app program file descriptor move structs file revision descriptor and comparison descriptor to move structs this to separate files. Commits. There we go. Good. Then yeah, we need to check like what's going on here with this assert. Yeah, somehow this container is not in sync with the file. But it is freed here. Selected all named function indices. Select. Selected matched functions. Well, we can put a breakpoint in here. And we put a breakpoint in here. Let's see what happened here. Actually, we can look at imgui functions selection. Let's go to our watch. This files 2. And then imgui selection. Aha, look at this. So somehow the selection, it has the old selection in there. So the bug is I see. Maybe we don't clear the selection, right? On a recompare, but we should handle it in a way where if the selection has too many elements, then we don't we don't use it up to like oblivion. Let's see, how do we use it in the other cases? Selected all name function indices. Update selected named functions. Reservation size typically matches selection size, but could be larger. Size, reserve size. What's the time? We're close to 2 hours. How about we take a break now and then we continue looking into this in the next session? Yeah, I think that would be fair. Yeah. I have a suspicion as to where the problem would be, but not yet quite 100% in the clear. Yeah. Okay, so this will keep us busy for the next session. And what else do we need to do? We probably, yeah, so there's probably, let's look at this next session. I think there's more cleanups to do in ImGUI app. There's this one big function at the bottom which contains a lot of UI code for the comparison window. We need to split this up, but I think before we do the splitting, we should polish the stuff that is currently in the comparison window to allow resizing of the elements before we move it around, I think. Yeah. Okay, anyway, I will take a break now. I wish you a great day or night. Until next time. Goodbye.